Okay. The second important function of surge tank is that it works as temporary water bank. Okay. When the load on the turbine is suddenly reduced, large amount of excess water is stored by the surge tank, and when load on the turbine is suddenly increased, it supplies the excess water or additional water required to the turbine. Okay, so this is second function, important function. It works as a temporary water bank. And first very important function is that it saves the pipeline from water hammer effects, that is possible bursting of pipeline due to water hammer effect. Okay, next is location of surge tank. So ideal location of surge tank is just at the inlet of turbine. This is because all the pipeline upstream of surge tank is remain protected from the effects of water hammer. So ideally this surge tank has to be as near as possible to the turbine. This is the ideal location, but many times this is not possible. Okay, so see, but due to topography of the sites and the fact that height in of the tank required to has to extend beyond the water level in the reservoir, then there are some constraints on the choice of location. So first constraint is the topography. Due to some reasons it is not possible to fit the surge tank at the just at the inlet of the turbine. And second thing, even if you install it, in that case h will be much greater. Now you can see that here in this diagram, particularly the simple surge tank is shown here. The top is open. Now if suppose water storage is at much higher level height, and if suppose surge tank is here and the top of the surge tank is suppose somewhere here, what will happen? Water will siphon off. Okay, so it is not possible always to locate the surge tank just at the inlet of the turbine, but the ideal location is that here at just at the inlet of the turbine it should be located. Okay, but due to some topographical constraints and practical constraints, so the surge tank is located at some higher level than this this ideal location. Now let us see uh, types of surge tank. Okay, now I hope you remember the diagram well. Now see here, the first one is simple surge tank. Here in what is happening, so this is the inlet, this is the water going to the turbine, and here a simple rectangular tank is constructed. This tank is having opening equal to its diameter or equal to its width. Okay, simple rectangular or circular type tank. And one more thing to note is that this is open from the top. Okay, this is simple type. This is restricted orifice type. From this side water is coming, and from this side water is going to the turbine. So here a small orifice or very small opening is there. Again this tank is open from the top. Okay, but here the contact area between the pipeline and surge tank is much reduced, just to fraction of what was earlier. So this was simple tank and this is restricted orifice type of tank. Okay, now third type of tank is differential type. Yes, so this is the water coming side, this is going to the turbine. Here there is a riser at the center. Okay, here the opening is small, okay, as that of a restricted orifice type. Okay, so when the water is coming into the tank, it goes into the riser, and from height of riser it falls to all the sides. This portion is called as a chamber. Can you see it? Yes, this portion is called as a chamber, and this central portion is called as a riser. Further, this chamber is connected by means of port to the main pipeline. Okay, so water when comes suddenly, it can rise up in the riser and it falls down to the sides in the chamber, and from chamber again it can come to the ports, and through ports it can go to the turbine. Okay, or directly it can come back from the riser and go to the turbine. Differential, this differential type of surge tank combines the merits of both these two. Okay, now, so simple surge tank. Okay, characteristics: open at the top, connected directly to the penstoke. Second, opening of surge tank at penstoke is unrestricted. This has very large opening. Okay. uh, very large size of tank. This demerit is that very large size of tank is required, so to avoid overflowing at conditions of maximum surge. Yes, you can see here it is open from the top, so you need much larger size of tank. Okay. Next, also it should not completely emptied during the maximum discharge to the turbine, as it would allow air to enter into the pipeline. Yes, you can see this and you can understand. If this tank completely, this water level completely falls down, what will happen? Air will enter along with the water and it will directly go to the turbine. Now this is very hazardous. Okay, that air intake will cause your turbine much greater way. Okay, it will affect your functioning of the turbine. Okay, so that should be avoided. So limitation is that huge size is required. Further, there is a possibility of a spill, of overspill, and there is also possibility of air entrainment in case it in case the water level comes down. Next, these types of water tank are not used nowadays, as it is sluggish in action and not economical due to large size. Simplest type, it is not used nowadays. Next is restricted orifice. Okay, so restricted orifice tank. The opening of the tank with the penstoke is very small, called orifice. Due to small size of orifice, throttling action of the orifice makes dampening effects very rapidly. Yes, as this is a very small opening, the dampening effects uh, happen. Dampening action takes place very rapidly here. Okay, and third type, the differential. Huh? The most advanced one is differential surge tank. In case of sudden closure of a valve, water flows suddenly in the central riser and spills over in outer chamber. As I told you earlier, this is the riser. So water enters into the riser and spills to the outer chamber. Okay. In case of sudden opening of valve, that means increased demand, water in the riser falls quickly, thus developing an accelerating head on pipeline which stabilizes the flow to new conditions quickly. Okay, the differential tank riser does the head building function, and while the chamber does the discharge function. This type of tank is smaller in size and more efficient than other types of tank. Okay, so head building function is done by the riser and discharge function is done by the outer chamber. So this is more efficient and used nowadays.